Bandwidth for this podcast is brought to you by Ideate Software. Be sure to check out all of their great Revit applications designed to increase your productivity. Hey, it's BIM Thoughts time! We made it. We're here. We're alive. I have waveforms in my waveformy thing, which means that you could probably hear me because I'm talking. Today, we have a great episode, a special episode. They're always a special episode, but this one is going to be wonderful because we have Sarah Causey and Dana DeFilippi, and we have Daniel Davis. So, Daniel, how are you?
Yeah, I'm doing well, thanks.
Good. Define yourself.
So I'm a researcher. I work at an architecture firm called Hassell, and I do research mostly on the workplace, but also have been doing some research on design technology and stuff like that.
Cool. Well, I was perusing the Twitter as you do, and I saw Sarah retweet a post from you, Daniel, about CAD. And it's like dead or something.
It's boring.
It's boring. It's horrible.
But
It's
in a
not
good
horrible,
way.
But in a good way. So tell us all about that.
Yeah, so the article that I wrote, it was looking at like the future of CAD, and I think in many ways, I don't know, I get asked to speak on what the future of CAD is going to be. Maybe you guys do too. And I think often people are expecting me to kind of go to those conferences and talk about like the latest technology, right? Like they want to hear about AI and they want to hear about big data and they want to hear about digital twins and stuff like that.
Mm-hmm.
And so the article is kind of looking at, well, what is actually going to be the big changes in CAD right now? And for sure, some of those technological changes are important, but I think there's also these other sort of shifts going on in the industry about how we use design technology that are really significant, but sort of underreported because they're a little bit, I guess, like boring or like more about the kind of business model behind how CAD is used. And so the article itself, it goes into kind of two main trends. One that I've called the fat metal over the long tail, and we can go into that one. And the other one focuses more on the verticalization of architecture over the sort of horizontal platforms that we're currently using. And then the article kind of rounds out with a number of like a lightning round of like little trends as well. So yeah, I'm happy to dive into any of those that you want to go into.
Well, I'm gonna let Sarah pitch in here because she was the one that found the article so interesting. Well, I read it, I thought it was interesting too. But Sarah, you're the one that thought it was so interesting enough to retweet to the world.
Yeah, my friend who I know you, Bill and Dana, you both know, Heather Worrell, actually sent it to me. And then, before I retweeted it. And I just think it's so spot on, Daniel, because there's a lot going on in the industry with buzzwords. I mean, it always has been, but it feels like more and more now with what we can do with AI and machine learning. And it's a lot of flashy, exciting things, just like you're saying. But at the end of the day, what is the meaning? What is the value behind it? And where is it most used? The thing I thought was so interesting before we dive in, but the overarching theme was not just what is the major, the boutique architecture firms or the major powerhouse firms doing with design technology, but what is the mainstream? What is mainstream architecture and design doing with design technology? And you kind of were able to cover that concept. What are we really talking about in the future of CAD? And I thought it was great. So yeah, you convinced me.
I always think that the future of CAD conversations are super interesting. But before I get into that, I must say that I love that we can't call Sarah a guest anymore. She's actually becoming like a host, and that is like amazing.
It's all because Carl convinced me to buy a real podcasting microphone. Like the rest is history.
There we go. Now you get to be a host with us. Daniel, what's your perspective on, and I'm sure, well, maybe the article goes into 3D printing and how CAD interacts, or how does it, like, it's a mystery to me. How do you start to plan 3D printing in terms of like what the concrete pourer is able to do and those types of things? I think that type of technology is going to be really fascinating and something that's going to throw CAD for a curveball for sure.
Yeah, I don't know. I think like that stuff's cool and all, but I'm not sure if it's got that much legs, Like, I think for sure the idea of building architecture in a factory and using robotics and stuff to help with some aspects of that, it makes sense. But going onto site with a 3D printer and printing concrete, like,
or
yeah,
even the modularity of it, right?
Yeah.
When we think about a lot, like you're saying, a lot of bits and parts of the bigger whole are built off site, and what we're seeing in terms of how those types of pieces are fabricated off site mostly. So are those types of pieces 3D printed, and we're just gonna have to deal with what the end outcome would be, and that's how we, even that type of modularity is super interesting to think about what CAD starts to look at with that type of fabrication.
Yeah, and I think there's like an interesting tension there, right? Like, we sort of have this assumption that designers have almost like absolute authority to make anything that they want. And if you're in a world where, say, modularity and repetition are really important for getting efficiency in the design process, then the idea that every design is going to be this unique kind of expression of the architect's desire or the site conditions, like, it might not kind of play out like that. And I think the way that like CAD software is geared and the way that we think about it in the industry is often in that kind of direction, and that there's this other kind of direction where this maybe composition of more sort of ordinary architecture is actually the more kind of interesting part right now.
Yeah, Daniel, there's a part of your article that compares building design to suits and the tailoring industry. Will you talk about that a little bit?
Yeah, so this is just like a little bit at the end, but it's in there because there's a lot of startups right now that are talking about, say, I mean, they're going to build architecture in a factory like we build a car or something like that, and or they'll use the example of ships, or they'll use the example of airplanes, or whatever it is, one of those kind of manufacturing industries. And I'm not sure exactly why it is that those are the industries that we often reference. There's a whole bunch of things in the world that are manufactured in all sorts of different ways that don't resemble cars and ships. And I actually think like suits and clothing is perhaps closer to what architecture is than a car. Like a car is this thing that goes on a road, and it has like the site for the car is basically the same. Whereas a piece of clothing, it goes on the body, and the body is always going to be different for the person that wears it, and their identity is going to be different. So I think what's interesting when you look at the history of clothing is that, like, at one point in time, it was highly bespoke. You either made your own clothes or you went to a tailor that would make something custom specifically for you. And then we went into a period of mass manufacturing where clothing was made in factories. And you sort of got one size fits all, which worked for some types of clothing like t-shirts, which are somewhat, say, forgiving in their form. But like for other types of clothing, like a suit, which is like highly dependent on the body of the wearer, like one size fits all didn't work particularly well unless you had that kind of idealized body that they'd used as the basis for that suit. And in the last, say, 10 years, one interesting kind of trend in fashion right now is this sort of made to measure fashion, which isn't exactly one size fits all. And it's not like completely bespoke. It's more like a sort of a parametric model for clothing where they take your measurements, they make something that's to your measurements but not entirely bespoke, and they send it back to you. And that's all enabled mostly by the internet at the moment. I think that is kind of a metaphor or example of where architecture might go, is maybe a more powerful kind of example, because you can imagine then like architecture that's not one size fits all, this kind of container modular architecture that you see around the place, and not completely bespoke, like we are going to do everything over and over again, like it's a completely new thing. But maybe architecture that kind of is designed for the site, has this sort of parametric model, can adjust while still being within this predefined sort of bounds of what it could be.
Because that's what makes architecture different. That's what makes architecture great, is if you want to call it that. Is that designs are different.
But to play on that same metaphor, we still have the limitations, if you will, in the string, in the fabric, in the machinery, right? Like we still have that fabrication level of limitation, and we have to, well, we should design for that, unless we're weaving it or creating our own string and sewing it all by hand.
Well, if we're going to keep it affordable, yeah, the materials have to be sourced in a way that makes sense. Otherwise, if you get a custom made Steve McQueen suit, it's probably going to be outrageous. So in Daniel's curves that he's talking about, there is room still for that Steve McQueen, all the way at the end of the spectrum, high end. Like in your uniqueness spectrum diagram, you talk about the Guggenheim as, maybe or Sagrada Familia as maybe the high end design. But you're right, Dana, for the everyday or the quote unquote boring future, we're still using.
Well, it's not to say that we can't try to be innovative with those limitations, right? And I think CAD, with especially the computational algorithms and different things like that show us different opportunities and different design outcomes, that assist or aid in that really just by giving us more knowledge around the limitations that we provide. That's me and my ringtone. That's really embarrassing.
What's also embarrassing is I definitely said Steve McQueen, which is an actor, and I definitely meant Alexander McQueen, which is a fashion designer.
I thought you knew some fashion designer that was so cool I didn't even know it. I was
like, no.
Well, I am so absolutely out of the loop when it comes to design that you could have kept saying it. Now I'm like, oh yeah, that must be a really cool person. Like I honestly have no idea. Well, but to that point, we can still, with the string limitations, the fabric limitations, or that machine that I'm used to sewing on, we can still create really cool, really innovative things. I mean, I think it's not to just say that because it's affordable, it has to be pedestrian, right?
Yeah, and I think the article kind of goes into this a bit. Like, I actually think the more sort of exciting side of computational design is actually going to be in that zone, because there's a lot of constraints on those buildings, and the kind of more ordinary side, sort of like financial constraints. But because of that, they lend themselves really well to computational design in a way that, say, a more unique project, although it can be used sort of like for a visual effect, it doesn't have the same impact. So, yeah, I think we'll see a lot more kind of innovation in that area, and I expect it'll be pretty cool to see what kind of comes of that.
So, how did you get to this place, Daniel? To writing these types of articles and this type of thought. Can you tell us a little bit about the path that you took to get here?
Yeah. So I studied architecture in New Zealand And I, shortly after that, went and worked on Sagrada Familia for a while, doing kind of computational design work for the project, and ended up doing a PhD in computational design over in Australia. And I guess that's sort of how I got my background in design technology and stuff like that. And then I moved over to the States, and really when I moved over to the States, I was blogging quite a lot then. I started writing for Architect magazine, and I guess I sort of developed my voice through that process. And I guess the sort of accumulation of a lot of those things is this article here.
That's super cool. And for the listeners, the regular listeners, you probably know the last place I traveled prior to COVID was actually Barcelona.
Oh, cool.
I went to Sagrada, and oh my goodness, Barcelona, Gaudi is probably just the coolest architect I can think of. And so going around and seeing his work was just the coolest experience ever. So being able to work on it, oh my goodness, that would just be a dream.
Yeah, and it's one of those things, like, I mean, I'm still blown away by the things that he does, but when you sort of dig into a lot of the projects and get into this sort of reasoning behind why things are the way they are, I mean, it floors you, like just the sort of level of genius that he had to design the things that he did when he did it. Yeah.
Can you speak to that a little bit? Because I know a lot of people would argue and say that Gaudi was actually more of a sculptural artist than an architect. He was very much a model maker. And I mean, walking through the basement of Sagrada, you get a sense of his model space, and what that looked like a little bit. I'm sure a very, very small fraction of what that looked like. But can you talk a little bit about that process and the computational aspect of how that all played in?
Yeah, I think that's a common, I think, experience of his architecture, that you walk into it and it seems very organic and not haphazard, but it doesn't seem structured, like it feels like it's from another world, and it's hard to kind of see what's maybe behind a lot of it.
I don't know. It seems genius to me.
Yeah, and I think what you have to consider is that, like, the architecture, it is all curved and like going in all these different directions. But Gaudi had to work out a way to communicate how to build that on site 100 years ago, more than 100 years ago. And so a lot of the geometry that he used were things like surfaces that, although they're curved, there's always a straight line on them. So a thing like a cone, although a cone has a curve to it, you can always, no matter where you are, where a point is on a cone, you can always draw a straight line through that point. And so he used these kind of geometric constraints about how to communicate this thing that needed to get built, and use that to kind of compose the architecture. So although the architecture looks like it's this like very organic kind of branching structure or whatever, there's normally a really sort of almost like mathematical rule underneath it about how things get connected together in order to make it sort of comprehensible and constructible, which always, I think, I don't know, it always surprises me just when you dig into it, just how well thought out all of that stuff was.
It strikes me as incredibly well thought out, for sure. I mean, just walking through that space is awe-inspiring, to say the least. I mean, the play on light and, just the way that the structure is formed in and of itself and how grandiose the space is. It seems to me it's just a complete play on mathematics and genius, really.
I feel like maybe the computational designers out there who are in touch with the things that y'all are saying are this is going to sound so weird, are like the purest form of computational designer. Like the way that you're explaining the math that underlies Sagrada Familia, I mean, that is seen in nature all the time. The thing that always comes to mind for me is broccoli Romanesco, or Romanesco broccoli. I don't know if you've ever seen this. It is gorgeous. And it is nature, and it's just how it grows. And all of the form that created that, and we see this all over nature, is based on geometry and mathematics. And so it's sculptural, and it's beautiful, and it looks out of this world, and it looks like it has character. But that's what computational design can offer the architectural industry if we're using it that way. Not just to prove some program that we want to convince the client is needed so that we can win work, right? Or not just to automate something for the sake of speeding up the process, but if we can use it, to mimic nature in a way to create more strong forms or more beautiful forms, that's, for me, that's the purest form of design technology.
I mean, yeah, I think there's definitely a potential to use design technology in that way. But I also think there's other kind of applications of it that are also equally valid.
Keep going.
Yeah, I think that's the beauty, right? I mean, computational design is what you make it in so many different applications. But I think that, yeah, please keep going.
No, I think that it goes back to like the article, right? Like using these things to push the boundaries like that, like it's definitely fun, and I enjoy doing that work. But I think there's also this opportunity for computational design in a broader sense to impact more than just one building in Barcelona. As fantastic as that building is, and maybe you need a building like Sagrada Familia to really, I guess, do all the sort of R&D that's necessary to develop these methods and these techniques. But I think there's a broader application for them than just a single project.
You make a pretty bold statement to that effect in the article that says, rather than using computational design to make a couple of extraordinary buildings, designers are increasingly using these tools to make lots of mundane buildings better. So can you talk about a little bit, from your perspective, of what the quote unquote better looks like?
Yeah, like I guess I reflect a little bit on sort of what's happened in the last 10 years of CAD, right? And you'd go to these conferences and you'd see these just outrageous skyscrapers and buildings, like cultural buildings from around the world that really pushed the limits of what was possible computationally. But they didn't necessarily result in architecture that was more sustainable, or architecture that was more affordable, or architecture that was better to inhabit. Like it photographed better, but it wasn't necessarily like a nicer space to be in. And I think there's this opportunity to use computational design not just to push this kind of design aesthetic, but to use it to focus more on the lived kind of experience of architecture. And I mean, one place that I really experienced that in my professional life was at WeWork, where we were creating office space, and office space, I mean, the WeWork offices, they were nice, but they weren't some crazy design, like it was when you walked into it, a pretty ordinary office with maybe nice furniture and some glass around. But WeWork was doing all this really sophisticated stuff to understand how people were experiencing that space using, like sensors in the space and doing research on how people are using different things and feeding that back into the design process and making the spaces better and better with time. And I think through that repetition, they were creating better and better architecture. And that kind of goes and feeds into their design process, and it feeds into their algorithms they're using to lay out the spaces. And I think a similar thing is likely to happen as more sort of computational design gets applied to more of these sort of ordinary buildings, that there'll be this opportunity to take data that's being generated by these buildings, learn from it, feed it back into these algorithms, and really, I think, make them better. Because I mean, at the moment, architecture is for the 1%, the 99% of buildings that don't really have that much kind of architectural influence. I mean, an architect can work on these algorithms and potentially sort of spread their knowledge over a much broader set of projects than just influencing one or two projects.
Yeah, and that really takes it to a whole nother level. And we are seeing more and more students coming out of school with this as part of their core curriculum. So I think your prediction is probably pretty spot on, just, for no other reason than we will have the ability to go there very soon.
Yeah. There's definitely like I mean, when I was going through school, there's nothing like that, and there's so many people coming out with just awesome skills in terms of all this stuff. And I think you're seeing that the younger generation, the more concerned about, I think, the ethics of what they're doing and the design outcomes in terms of things like sustainability and performance. And I think you're going to see them really apply their skills in new and innovative ways in terms of that sort of thinking.
Mm-hmm.
Yeah, it's a little bit of a quandary, in my opinion, because, like Sarah had alluded to, and as I had mentioned, thinking of the idea of fabrication and how things can be fabricated or things being built off pieces, thinking about architecture in kind of a kit of parts, I don't necessarily would think that couldn't be sort of made to measure in the way that we're using it. And same idea that what you're saying of, maybe we both go to the market and we buy the same fabric. Maybe we both go to the market and we buy the same facade type. But what we do with that facade type and how we sew it and seam it together and, etc., how we wear it, right? I think that plays a huge role in it. I think also in the sense of where we are in the terms of sense of technology, I think we at the moment can do much more than modest tasks such as laying out desks in an office. So I don't know. I need to read through this more than I have, but it seems like I'm scratching my head a little bit at your logic.
Well, I think, yeah, one of the things that I've been thinking a lot, reading it over again, is the constraints of the future. Some of them we can't even see. So it's easy to say one constraint is cost. It's also easy to say one constraint is the footprint or the capacity on the site. But, with things like the global pandemic or you think of Miami and you think of coastal cities that are starting to experience, the effects of global warming, the constraints are going to start to become more and more complex, where we may be forced into some pretty unique opportunities or challenges to take design not just about what can we, in the past, what can we do with this blank slate? And yes, we have a constraint of a budget, but we may find we have to get more and more creative because there's 5 or 6 things holding us from doing maybe what we'd like to do in the virtual world with no constraints. So, that's yet to be seen, but I think we're going to feel that. Also, a lot of people have predicted increased urbanization. We have, Dana, you talked about this, I think, on our last BIM Thoughts, was how many buildings are existing that just need to be renovated, especially with the change in the workforce and work from home. That we may find that tenant fit outs have a whole different new set of constraints we didn't have before. And generative design is a nice path where you can test multiple constraints against each other to try to find the best outcome.
Yeah, that's a fantastic point because we are in a world that is ever changing, right? I mean, not to mention with technology and what, you know, building uh, pieces and parts, right? I mean, if you look at steel and lumber right now, my goodness. Um, but also what the buildings in the terms of the types and the program, what those are going to look like tomorrow. I think that that is an absolutely interesting and integral part of what tomorrow looks like.
Daniel, what are you seeing trends wise with that in your region of the world?
In terms of like the workplace?
No, just tighter constraints or changes in constraints in design due to the changes happening, whether they're related to the pandemic or whether they're climate change related. Are you starting to see clients, examining more constraints than they did 10, 15 years ago? Or is that still future?
I think like we've always been in a situation where it's been sort of pressure to do more with less, and I think that's only accelerating. And I do think it's true that, I mean, issues like sustainability, clients are coming, pushing for that more and more, and I think asking for it more and more, and that's, I mean, yeah, I think this sort of changes in expectations. I'd say maybe one of the other things happening there is clients are also better informed about the performance of their projects. So they have a lot more data coming back from projects. They're getting a lot more feedback from people that might inhabit them. They might have sensors or something in these projects, and so they're much more aware of how projects are performing, and I think much more concerned about the performance of projects than maybe they would have been in the past.
Mm-hmm.
Are you guys seeing as well a big influx in the rehab or renovation of buildings, whether because you have a lot of old buildings or because of the, you know, happenings of today?
Yeah, we do a lot of workplace projects, and definitely, I mean, everyone that's got a workplace right now is thinking about what role, if any, the workplace is going to have in their future. And we're seeing a lot of projects at the moment for people that are um, redesigning or rethinking sort of how those building types will be.
Yeah, and I think as Sarah mentioned, the way computational design can play a role in that will be wonderful, right? To be able to place all of those restrictions in, especially within the restriction of an existing building.
Yeah, and there's some cool tools out there at the moment for doing different types of like office layout and stuff like that. Really sort of focused on just a really small vertical. So yeah, I think there'll be more innovation in that sector for sure.
Absolutely. Or, making them not office at all, right?
Yeah,
Making them into something completely different. Well, being that we are just over an Aubin, our 30-minute mark, if you will, you have anything that you'd like to wrap up on? Any final thoughts that you'd like to share with the audience?
no, this has been fantastic. Yeah, thanks for having me.
I do want to just take a moment to congratulate you on your engagement. For all the romantics out there, he talks about how the jeweler used rhino and it surprised him. So, to design the engagement ring, which is really cool. So, but congratulations. That's super exciting.
Cool, thank you.
That is very, very exciting. Sarah, any final thoughts that you'd like to share?
No, I think it's wonderful to have you on here and sharing your perspective. And I think it's a vulnerable and bold place to write articles like this that really take a stance. And it's interesting. I hadn't, like you said, most people are talking about the shiny gold rainbows and butterflies. And, you took it to a very real and critical but real place. And so I appreciate you stepping out and taking stances because it definitely made me think. And it sounds like Dana and Bill as well. So I appreciate that.
Daniel, any way that our audience can get a hold of you, get in contact with you?
Yeah, my website's danieldavis.com, and that's got all my social on it and my email if you want to reach out.
Fantastic. We'll make sure that is in the show notes. Well, thank you so much, Daniel, for joining us. And Sarah, pleasure to host with you as always.
Me too.
From Bill and I at Vim Thoughts, and from Carl that is not with us today, thank everybody for listening, and thank you especially Daniel Davis for participating today.
Cool. Thank you. I'll see you later.